Okay, I'm going to start on the level 3 questions. The first one is sine to the 4th x. By the way, I've replaced this, as you can see, with one that functions properly, minus cosine to the 4th x. This came up earlier in one of our seminars in some of the practices, that when you see like a to the 4th minus b to the 4th, that this is actually a difference of squares. And really, if this is any even number, if this had been 6, this would be cubed squared. If it was to the 20th, it would be to the 10th squared. But any even number, it can be split like this. And then what you have to remember is that this is the first parentheses minus the second, and then the first parentheses plus the second. So the way this factors is not sine squared minus cosine squared squared. What it is sine squared minus cosine squared times sine squared plus cosine squared. At this point, this is 1. So this is sine squared minus cosine squared. Then you check here. It looks very much like this one, it's just reversed. So that means it's negative this. So negative cosine 2x. A negative changes all the signs. So this should have been negative, this should have been positive. The signs were changed, so it's negative of it. That is your, so the two things that needed to be recognized were 1, a difference of squares, 2, that needed to be factored properly, 3, you needed to know this Pythagorean identity, and then 4, you needed to make the connection between this and this. The second level 3 for most of you was more difficult. I think there's some stress about having to look at the multiple choices to know what to do. Normally, if you were doing textbook problems, you would be given two things which are equal, and it would say prove that, which you have done. On the previous concept check, you've done that. In this case, because it's not this is equal to this, now prove it, you're doing it a little backward. You're seeing where the proof would lead you, but it's got to land at one of those two. So normally you have that other side, and you figure out how to substitute to make it match that other side. This is the same thing. We're just not sure which of the 4 we're trying to match. So that's how it's both the same and different. But if you were given the two equals, you still have to say, well, what I've got over here, I want it to look like that over here, so how do I substitute to achieve that? It's the same, it's just there are 4 potential things on that other side. So we had 1 plus sine 2x minus cosine 2x over 1 plus sine 2x plus cosine 2x. For the sine 2x, you only have one option. It's this one. For the cosine 2x, honestly, you can use any of these. Depending on which one you choose, you may or may not have to recognize something on the next step. So we automatically have to do this. No option. Put that on the bottom as well, real quick. Now, as far as the cosine 2x, you can pick. You can do them differently, you can do them the same, you can do whatever you want. If you, for example, did cosine squared minus sine squared, as some of you did, most of you, when you did that, you went ahead and substituted anyway. Like, instead of cosine squared, you'd write 1 minus sine squared, or instead of sine squared, you'd write 1 minus cosine squared. That's actually where these come from. So if you started with this, you were going to end up with one of these anyway. So I'm going to put one of these. Well, and if you didn't, by the way, if you put cosine squared minus sine squared and then said, now what the heck do I do? it is a perfect square over here now, but then it doesn't help you. But if you had looked at the multiple choices, you would see that 3 of them have not a 1 anywhere. They have no numbers. They're all functions. One of them has a 1, but only on the bottom. So there's no way that you want to keep both of these 1s. Looking at this one, you can get rid of the 1s. If you do this one on the top, then you're going to end, so let's say that you do that one on the top and bottom. On the bottom, it gets rid of the 1. You get the 1 minus 1, these cancel, and so that's good. Up here, though, you end up with a plus 1, so now you've got 2. So that one does not work. You can keep going and try to manipulate it, but the easiest thing to do instead of going through the manipulation yourself is use the manipulation that had already happened here and substitute the other one. Because you know you want to get rid of the 1s. Down here, you can add a negative 1. Up here, you need to subtract a positive 1. So that's how, if I were doing it, I would have used these automatically because I would know I want to subtract the 1 in both cases. And on the top, I already have a minus, so I'd get the positive 1. And on the bottom, I have a plus, so I'd take the negative 1. So that's what I would have done to start with. Any way that you started, if you want to come to me and say, I started this way, I'll show you how to get from where you started to here. Oops, so this is gone. Okay, so now the 1s are gone, and this is a plus. People are coming in now, so it's going to get loud. I'm going to put this up here and then erase. From this point, now we have 2 sine A cosine minus 2 sine squared A over 2 sine A cos A plus 2 cosine squared A. And a factor from the top, we know we need to simplify it. None of them are this complicated, so we look for ways to factor. I can take 2 sine A out, make cosine minus sine. Oh, sorry, this is a plus. These 2 minuses made a plus. So this is plus. And then down here, we have 2 cosine A. And it's sine A plus cosine A. These are the same, they're just in reverse order, so now they cancel, and the 2's cancel. And sine A over cosine A is tangent A, and that's the result that you would have chosen. So that is all of the level 3 questions, and I will have to wait until later to make the level 4.